Hello everybody, good morning, good afternoon, good evening, wherever you are. Welcome to this ShapeBlue webinar on Apache Cloudstack 4.15, first look at 4.15. This is a ShapeBlue webinar. We're talking about the latest release of Apache Cloudstack. Today presenting is myself, Giles Sirett, I'm CEO of ShapeBlue, and Paul, our CTO, who's also the release manager for the 4.15 release of Cloudstack. Are you here, Paul? Hopefully you are.
I am. Hello to everyone. Good, good whatever it is, time of day it is to you.
Actually, that's quite interesting. I had a quick look at the registration before we started. Looking right now, we've got 90 people on this webinar, but I had a quick look at the registrations from 23 different countries. And I know for a fact that some of the people who are listening to this have had either very early mornings, and there's some people who have got some very late nights to listen to us. So thank you for taking the time to listen. We're going to keep this to an hour, hopefully allow some time for Q&A at the end. In terms of the agenda today, just going to talk quickly about the release and its metrics, etc., timeline, and then we're going to start just diving into features. As the title suggests, this webinar is a first look. We're not going to go into massive detail about these things. The idea is to really make you aware of the new functionality, point you in the right direction, where to go and find further information, and time permitting, we'll demo some of these things. If you have questions to ask, we're doing this as a webinar, not as a sort of interactive thing, so we'll keep everybody's mics muted. If you have questions to ask, please use the go to webinar question button. It looks different depending on what OS you're on or what device you're on, but somewhere you will see in that window a question button. We will then see that list will build up. Please ask the questions as you go through, and then when we do Q&A at the end, we'll work through your list of questions. Okay, so 4.15 is the latest release of Apache Cloudstack. It's been a long time coming. It's definitely later than it should be. In terms of its scale, it's about I'd say a standard size Cloudstack release. All in all, we've got about 200 PRs that are going into Cloudstack. That turns itself into 13 new features, 59 enhancements, 128 bug fixes. So actually, it's probably new feature light. And in fact, out of those 13, I think we discussed we're going to go through all of them today. But there's a lot of smaller enhancements, a lot of bug fixes gone into it as well. Reason it's late, it's difficult at the moment with what's going on, and people probably aren't spending as much time in open source communities as they should. But we found this with the last release back in May as well, that it's taking longer to get everybody to get their PRs across the line, get them merged and that sort of thing. But actually where we are at the moment, we were at code freeze some weeks ago, and we should have it released by the end of November. What we're working with today is a recent build which has most of the functionality in. This release 4.15 will have its standard 2-year LTS support from the community, so effectively it will be end of life late 2022. All right, so let's dive in and start looking at some of the new functionality. I'm going to take you through some of them. Paul's going to do a few, and then I'll finish off with the last few. First thing is the new user interface for Apache Cloudstack, which I'm sure everybody on this webinar has heard about before. That is now at GA. Okay, that's now fit for production use. It now has complete feature parity with the old user interface. Okay, effectively that is now Apache Cloudstack's interface. Those of you who hadn't, hopefully everybody's heard about it, but we've got a new modern UI that's based on Vue.js. It's a lot easier to use, got a lot of easier to manage, to install, and a lot easier to work and develop new features in. It's all round a better experience. Everything you see today is all going to be obviously using the new UI. 4.15 will ship with the old UI, but that's effectively for backwards compatibility only. And make note, it doesn't contain any of this new 4.15 functionality, because part of the process the community had of moving to this new UI was we would put a feature freeze on developing the old UI between 4.14 and 4.15. Okay, so if you want any of this new stuff, it's only in the new user interface. So it contains, well, actually it's worth mentioning here, between 4.14, when the new UI was at tech preview, and 4.15, there's a number of things that have been done. And when we talked about the 4.14 release, we said, look, these things will have to be done before it becomes GA. So it now has all 4.14 and 4.15 functionality. It now supports all network service providers. All of the translations for there's 18 different languages we support are 100% complete, and it's fully documented. The only sort of slight outstanding thing there is in the general CloudStack documentation, there's still quite a few sort of screenshots and things which are referencing the old UI, and that's just a background task. It's effectively not in our critical path for the release, but that's a background task that's going to go on over the next few months. So as I said, 4.15 is the last version to ship with the old UI as well. Doesn't contain any of this new functionality, and 4.15 also contains a formal deprecation notice of that old UI. Okay, that notice is telling everybody that at the next release, before 4.16, which will probably be early next year, the old UI code will be stripped. So where I'm going with this is, if you are exposing the old user interface to your user base, you need to take some action now, okay? Because that user interface is not going to be actively maintained going forward. It will have high-level bug fixes applied to it as part of the LTS strategy, but nobody is going to be developing features or maintaining the old UI. And just one note as well, you will have heard before us talk about Project Primate. In fact, you'll still see this talked about in different places. That was the code name for the new UI before it became sort of part of CloudStack, and that code name is effectively getting dropped. So we're just now referring to the new CloudStack UI, and eventually we'll just refer to it as the UI, not the new UI. Okay, next new feature, it's just some enhanced operating system support that's gone into 4.15. We now support CentOS 8, so I think currently that means we support CentOS 7 and CentOS 8, both to run the management server on or as a hypervisor host with KVM. Ditto Ubuntu 20.4, and we now also support XCPNG 8.1. Yes, somebody did ask me the other day, yes, we are still supporting Zen server, but we're seeing a lot of people taking up XCPNG with their CloudStack environments. Okay, secondary storage management. So this is a whole new set of functionality that's been driven around the fact that we've never really had any tooling for managing secondary storage in CloudStack. You think about the sort of situation, you set up your secondary storage pools, maybe one, maybe multiple pools. Generally at the beginning when you build your environment, you might then add another pool as things grow. But the sort of use cases, thinking about needing to decommission because you're changing the underlying infrastructure, needing to remove a pool, add a new pool, and balance your artifacts across those pools. So what's been built here is a whole set of management tools for looking after secondary storage. What we can do with these tools, first of all, really importantly, we can balance data amongst data stores. So we've got a one-off migration process you can go through to say to CloudStack, okay, here's a number of data stores, go and balance, as in when I say balance, I'm talking about disk space, go and balance all of the artifacts across those stores. So I'm not in the situation where I've got near 90% usage on one store and then I'm only using the other store by say 5% or something like that. The ability to migrate data between data stores. So the idea of, okay, you want to decommission a data store because that physical device is being removed or something. You want to easily be able to migrate the data away from it. Being able to set a store to read only for lots of different reasons. We've also got a new allocation algorithm. I'm going to talk about that in more detail. So that's about the ongoing balancing of artifacts across these data stores. And also some work's been done in monitoring the progress, the download progress of templates across different data stores. Now, all of these things, you know, we've always had to do all of these things when we're running a CloudStack-based environment. But to be frank, it's been pretty hacky. So, you know, moving data from one data store to the other would be a question of, you know, using rsync or something, you know, copying the data over and then going and hacking the database to tell CloudStack where those artifacts now are. We've now got a controlled, reliable mechanism which will take care of all of this stuff automatically. Okay, so we've got a new API, a new set of API commands. Migrate secondary storage data is the one we're going to look at to start with. And this does what it says on the tin. You give it as a parameter the secondary storage pool you're migrating from. Let's call that storage pool A. And then you give it the pool, the destination pool that you want to migrate to. Here's the really clever bit. We can give it multiple pools in the destination. So I can take storage pool A and migrate that to both B and C, okay? I'll explain why you might want to do that in a second. So it's got two modes it can operate in, either complete or balanced. And complete migration is pretty straightforward. That is basically migrating all of the stuff from A to B or B and C, okay? So the sort of use case around that would be you're about to decommission A, and you want to move all of the artifacts out. So you just run migrate secondary storage, source pool A, destination pool, say B, migration type complete, and that will migrate all of the data out. It has a threshold, it has a number of checks, but the main threshold, the main thing to bear in mind, it won't take anything once the destination's hit 90%. And that's a limit that's been around in CloudStack for some time. That's effectively a hard-coded limit. So this automated process will stop at 90% for obvious reasons. Balanced migration is a much more nuanced thing. And this is a process you can run to take your existing data stores and automatically balance out across them. So let's say, again, you've got stores A, B, and C, but A is very, very full, let's say at 90%. B and C are right down at 20% or something like that. What we would do then is run the migrate secondary data storage command, set A as the source, B and C as the destination, okay, and specify that we want to balance them out, okay? And it's worth noting you can actually put the source in as the destination as well, which would actually probably be better for my example there. So I could take A and spread it out across A, B, and balance it across A, B, and C, okay? It's quite clever the way this works. There's a global setting called image store imbalance threshold. And that's the standardized or the mean standard deviation that CloudStack is going to aim for. The default is 0.3. So what it's saying is, if I'm being told to balance, I'm going to try and balance everything by moving stuff around to get them within a 0.3 standard deviation. Okay, this is all in the UI. In fact, let's just have a very quick look here. If I go to, oh, you see my UI, okay? Or somebody?
I was on mute, sorry, yes.
Yeah, thank you. I'm looking for secondary storage, there we are. Oh, wrong place. Infrastructure, secondary storage.
Yeah.
Okay, so I've actually only got one pool in this environment I'm running at the moment. But I've got a new button here, which is migrate data from image store. I choose where I'm going from, where I'm going to. You can't see, unfortunately, here because I've only got one pool, but I could choose multiple pools in there and then just choose the migration policy that I want to run, either balance or complete. Off CloudStack will go and automatically start either balancing or moving stuff from one place to another. Okay, there is a lot of validation that goes on because these are effectively sort of batch processes. So it's got to do a lot of checking to make sure it's not going to corrupt anything. All sorts of validation checks are performed, you know, making sure, you know, none of them are read-only, making sure that they're valid image stores, etc., etc. And there's a whole load of checks going on. One of the important things there is there can only be one of these type of migration jobs running in the system at any given time. If you try and run a second one at the same time, it's going to throw an error and say, sorry, I only run one at once. That's for obvious reasons, so we don't get effectively concurrency issues with two of these things trying to balance each other out. One of the potential problems, of course, is snapshots, linked snapshots from things like Zen server. Fundamentally, whatever sort of migration you're doing with these tools, linked snapshots are kept together. That's the important thing. We don't want the situation where we've got, you know, half of the chain in one data store and half in another data store. And there's a whole lot of validation around that. It will move, if it's able to, an entire chain. If it can't for one reason or another, it will leave the whole chain in place. Now, obviously, this could have a lot of work to do. A lot of people with very large secondary data stores, and these processes could be quite intense. And also because, you know, the way CloudStack works with secondary storage through the secondary storage VM could present some sort of network challenges because there's a lot of data being moved around from place to place. So there's a set of configurations you can use which control how these migrations work. These are all global settings. So first of all, you've got sec storage max migrate sessions. This defines how many threads effectively, how many file transfer operations can happen concurrently on a secondary storage VM. Okay, and default is 2. Tweaking this will depend on you know, your size and performance of your secondary storage VM, how much sort of bandwidth you want that one secondary storage VM to start to eat up, its interfaces, etc., etc. So that can be tinkered with. After that, there is an automatic mechanism where the secondary storage VM will start spawning further secondary storage VMs to do more and more of this in parallel. Okay, so we've got two settings, which is max data migration wait time. Paul, I think you've left your mic open, by the way. After this time, CloudStack will look and say, okay, I've waited 15 minutes. It's been ongoing for 15 minutes. I've still got work to do. I'm going to go and spawn another SSVM and let it now take its 2 sessions and start working concurrently. And then we can it will keep going and it will keep spawning additional SSVMs to increase the performance until it hits this max SSVM count parameter. So the idea is it's effectively auto-scaling itself to try and do that work as quickly as it can. A couple of other things we've got. We can now set a secondary storage pool to read only. It's quite simple as the API command, or it's in the UI. And we've also got improvements in the actual allocation algorithm for secondary storage. So this is the algorithm that's used when artifacts are actually placed in secondary storage. This is not a one-off process. This is the ongoing thing. And traditionally, this has always been random. CloudStack has basically just, if it's seen 3 pools, it's literally gone randomly, which one shall I put it on, which is effectively creating a sort of round robin style, which is fine if you created all of those pools at the same time. Then statistically, yes, they're going to feel roughly in line with one another. But if one of the pools is a new pool or has had a load of data archived out of it, that might sit at much lower usage than the other pools. So we've got an option now, rather than random, which is the old way, with this global setting, we can set first fit, least consumed. Okay, so it's the first secondary storage pool that fits the job and is the least consumed. So by definition, what CloudStack is doing is then balancing out your secondary storage pools for you. Last minor change, which was part of this, was the ability to get the download status, the percentage download for a template. It's always had an annoying thing that if you're looking at it across multiple secondary storage pools, that you would only get the download status for one of those pools. And I think, if I remember rightly, it was almost random which one you got it from. Now you get by calling list templates, you get information about it in each of the different secondary storage pools and what percentage downloaded it is in each one of those. Okay, so that's that. Paul is now going to talk to us about some advanced Vsphere capabilities. I'll just make you presenter, Paul.
So the advanced Vsphere capabilities. The reason we've gone here is because I think for the last couple of years, a lot of people have been looking at KVM, and so it's kind of got a bit more love, as it were. But in the meantime, VMware haven't been sitting still and have been adding more and more features, and so we thought it was about time we caught up with those. So that if people are going to choose between Vsphere and KVM, they've kind of got a bit more balanced of a view, rather than just kind of going, well, we've got old stuff in Vsphere and new stuff in KVM, so it's making our mind up for us. So on those, what we have been looking at and adding is support for vSAN, VMFS 6 if you're running it as kind of fiber channel iSCSI at the back end, vVols and datastore clusters, and kind of supporting a lot of that is the storage policies. A lot of those other data store types kind of assume that you've got storage policies in place already. It's giving us another feature, which is being able to do inter-cluster VM and volume migrations when they're live. So that's quite a benefit, and you don't need shared storage to do it. So if your storage is cluster scoped, you're not stuck. You can still live or cold migrate them across. And one of the ways we've gone about this, and one of the kind of just things we wanted to do, was go and use the native API that Vsphere give us in a couple of their different SDKs. Before, we were doing quite low-level actions. We were doing bit copies of things, partly because the specific features that people wanted back when this dates back to, I think CloudStack dates back to Vsphere 4 in some places, just weren't possible. You just couldn't do some of the things that you can do now. And the then way of doing it kind of was shoehorned in, but now Vsphere have covered all those, and our view is, I think sensibly, well, Vsphere knows how to do it, so let's let it get on with it. And so we've then gone and looked at a lot of the operations we do, and then looked at the Vsphere API and go, well, is there a version of this available that actually is better and native that we should be using? And so some of the very fundamentals of creating volumes, attaching volumes, creating snapshots, creating templates, creating cloning VMs to create them as from templates, but also the actual process of deploying the template in the first place. And we'll come back to why that helps in a moment. So, as I say, the use of the native APIs is giving us, obviously not for free, but is giving us a lot of versions of storage that we didn't have before. Before, the way we would have done it is individually code support for these, so that we would have to basically understand and work out how vSAN worked, and do bit copies, if you like, which is almost not possible in vSAN. The same with vVols and VMFS 6 is presented in a completely different way to VMFS 5. So what we're doing instead is saying, well, vSphere knows how to do these. If I just tell it to move this VM from there to there, I don't need to care what's underneath that. I don't, and CloudStack doesn't need to know it's going from 5 to 6. If vSphere can do it, we'll just tell it what we want it to do, and it'll do it. So that's kind of how we've got those extra features by doing this. When setting it up, we still use the old pre-setup kind of thing. So there's no change in that level of what people need to know. A pre-setup basically says we don't know as CloudStack what you've set up in the back end. You can set up whatever you like. Anything that vSphere supports in terms of a storage type that it would be presenting. Previously, we are going to just take the name of the data store you give us and put things in that. And if that's presented as iSCSI on the back or fiber channel or anything else, we're not kind of going to check on you. We're just going to assume you connected it all up. And even down to our presentation of data store clusters, we are obviously going and abstracting the data stores that are underneath that. So as a user or as an operator, you don't need to look at which storage pool underneath. As clusters work, you just know the name of the cluster, which is obviously usually tied to a storage policy, and then go from there and just say, I want it in that cluster. And it goes in that cluster because you're, by definition, not really interested in exactly which storage pool that is, which data store that is underneath the cluster. So talking of storage policy support, I've got a couple of shots there. You can see in the vSphere client, a whole load of policies. And we go and import those policies so that when you're creating a service offering or a disk offering, you then can tie that disk offering to that storage policy. You can actually look at vSphere's storage policies very much as actually being the same as CloudStack's disk offerings. I'm not going to suggest that vSphere copied us, but the mechanism is pretty much exactly the same. So we then tie our disk offering and add the vSphere storage policy to that. So we go and get them whenever we add a vSphere zone, but also whenever there's an explicit API to go and fetch those, because obviously over time they may change. So we have to go and get what they were so that we have an updated list, or you have to go and get what they are to have an updated list. But otherwise, the create disk offering, it works exactly the same. You basically just have an extra option to say which storage policy you're going to, or if any, that you're going to bind as part of this offering. And trying not to dive too deeply in, and say the storage policies are kind of like a filter. So we then go and ask, based on that storage policy, which pools are suitable, and vSphere returns those, and then we kind of go back to our normal filters that we would use for the deployment planner, deciding if there's tags or what have you, and where you go from there. I think I did kind of mention this earlier on, but it's worth mentioning again. The running virtual machines. So we can move them between clusters, but we don't need zone-wide storage. So for anyone who doesn't know about that, we can either scope our storage to a cluster, which was the traditional way, but also we can have storage that spans entire zones. Used to have that kind of shared storage so that you could basically not have to move the VM's disks, but only move the compute. vSphere is quite happy to move things around between clusters, even when they don't have shared storage. So we are leveraging that now to make those clusters migrating between clusters, which is especially helpful for people who say want to decommission one cluster because the hardware's old, but don't want to shut down all the virtual machines while you're doing it. which segues nicely into this second point. What we did have to do, because even when a virtual machine was stopped, well, in fact, we couldn't do it at all when it was running. When it was stopped, we could, but we used the secondary storage as a kind of staging area, a pass-through. So we'd go to the secondary storage, which we could always access, and then from the secondary storage to the new cluster, because that always works. But that's obviously moving a lot of data and involves shutting the VM down. So that's why we've done that. It means you don't go through secondary storage, it speeds the whole process up, and it gives the option to do it live as well. And again, for our compatibility, we're doing this in the back end, so the original APIs still stand. You still use the same API that you would have before to move something. It's just that now it's capable of doing more than it did under that. So this is basically, as it said, required a kind of major refactor of what we had there and how CloudStack was using Vsphere. So, as I say, we're kind of using Vsphere's abstractions rather than diving down in the bottom. That's given us being able to create volumes directly. We used to have to use kind of a worker VM because Vsphere didn't have the really the concept of a disk being separate from a VM so much. So we had to put it in a kind of dummy VM to move it and then take it out again. But now we don't. We can do, Vsphere can move that for us, create it somewhere else. Again, volume snapshots. We kind of did quite a long-winded process. Long-winded is the wrong way. It was complicated because it needed to be. But now we're able to just ask Vsphere to create a snapshot of the volume. And it does it extremely quickly, very efficiently, and it's all kept now in Vsphere's own kind of purview to do it. And the creating a template from a volume, the same really applies there. We're not having to get down in the weeds to make this happen. We just make an API call via the SDK to Vsphere to ask it to do that for us, please. How are we doing? Good. So something that kind of segues into this is what we've called full OVF support. And that's for, if people are aware of this in VMware, when you have what usually they're known as appliances, but there are other normal virtual machines, servers or what have you, that would have basically extra properties, what Vsphere calls custom properties. And previously, CloudStack imported the OVF or OVA actually, took the disk out of that and then deployed the disk and added on things you'd asked it to, like disk controllers, NIC control, network interface controllers, and all of those things. But that did mean that there was a whole load of potentially useful or potentially very important data that got left behind, these custom properties. Which meant that, for instance, a lot of vendor appliances just couldn't be deployed via CloudStack because that information was key to it starting, or at least being configured after it started. I'll show some kind of screen grabs of that kind of stuff in a moment. So, well, actually, I can say, so we can now support multiple disks within a template, not multiple VMs, but multiple disks. So if any template requires multiple physical disks, we can now deploy those as they were intended. As I said, the initial parameters are there, but also licensing and EULA acceptance, which is obviously quite important to everyone, especially the appliance manufacturer. So they are in there as well as something that can be, or it has to be filled out. So the first step in this process is registering the template. In terms of what the operator sees, and certainly the user sees, we are just using pretty much the same process. You're saying what you're importing, where you're importing it to, and what it is, i.e. the hypervisor. I'll skip a bit and come back to that at the bottom. We are storing those properties. We store them in a table in a database. And we're storing all those configurations, the network requirements that are in there, the custom properties, and the end user agreements. And if anyone's ever opened up an OVF, the descriptor, which goes with any appliance, there can be a lot in there asking lots of different things, requiring lots of different things, and then you need to fill those out, and they can be a lot and they can be long-winded, and in fact you see them in a bit, but we store all of that to be used later. One of the things we've, funnily enough, taken out is the question where you ask the end user what kind of disk controller they want, and what kind of network interface controller they want. You can override this in some cases. This behavior I'm going to explain, but what we know is a template was created with a specific disk controller, and actually changing that could well break it. The one off the top of my head was when Windows Server 2019 dropped support for one of the disk controllers. If an end user was importing a template of that and used the one where the support had been dropped, they wouldn't be able to start it.
So as Paul says, the use case here is around being able to easily deploy appliances in CloudStack, and to be able to read from the OVF all of the configuration information that's required to correctly deploy that appliance. So use case around network appliances or any other appliances, any vendors who ship an appliance, rather than us having to specify all of that when we register the template, or the user having to guess it when they go and create a virtual machine based on it. We're reading all of that in from the OVF properties, disk image, the initial configuration, the licensing, the EULA, etc. Okay, so I think that's just about where Paul had got to. We've got this concept, the deploy as is option, which is only used if you're using the OVA format. Paul said it can be overridden. This is the default behavior for OVA formats now, which means you need to make sure that those OVAs are correctly configured before trying to import them into CloudStack. Okay, so here's some examples. As Paul says, we read the configuration out of the OVA, and we're then storing that in a table in the CloudStack database as JSON, as a series of key value pairs, depending on which bit of the OVA file it's from. Okay, so here's an example of network interfaces where we're describing the network interfaces. Configurations. Now, configurations can be used in the OVA format for a lot of different things. We're really only bothered about the CPU and memory from a CloudStack perspective. So you can see here, this is a real life example of a Cisco ASA version 5, and that's the CPU and memory configuration it wants. So what we're doing in CloudStack is storing that ready for when somebody deploys a virtual machine on it. We'll be able to read that and configure a service offering appropriate to run that appliance. VApps, we use the VApps properties. Now, to be clear here, we're talking about a single VM. We're not talking about VApps in the context of lots of different VMs deploying at the same time. But we use those properties because that's where random things tend to find their way. Example, I don't know what sort of appliance this is from, probably something like a Cisco NetScaler or something, and that wants to know at boot, it needs to know the management address. Okay, you have to put that in when the thing first boots. So obviously from our perspective, what we want to do is during the creation of the VM, be able to specify that, okay? And what we're doing here with this JSON, we've got the ability to, push this straight in as the VM is created, or to prompt the user as part of the create VM process. So the VM deployment wizard, the new VM deployment wizard, first of all, it identifies when a deploy as is template has been selected. Okay, it then can read the different sections and the required inputs and defaults from each of those sections from the OVF descriptor. Okay, and it will display those as part of the UI wizard. Okay, so there's an example there. Hardware configurations being mapped to compute offerings. That compute offering is being specified when somebody's creating a VM, because the OVF in its configuration says that's what it needs. It needs that many CPUs of that particular clock speed and that much memory. So we're pre-deciding that and saying this is what you need to support this appliance. Okay, network information, again, where it's predefined, is going to be pre-populated. VNICs, what position, what order they're in, again, is all going to be pre-populated in the deploy VM wizard. Users still got some control here, but what we're doing is putting in the default that's required to actually underpin an appliance like that. As an example there. Using VApp custom properties. Ah, he's back. Hello, Paul. Are you here? Nope, he's not. Okay. VApp custom properties. So I don't know what sort of device this is for, but it wants to know the administrator password, a username, a DNS server. It wants to know whether to enable HTTP, enable its REST API. These are all of the things that you would configure when first deploying a device, an appliance like this. Again, we're doing all of this as part of creating the VM. Finally, and really usefully, is the ability for people. These appliances won't boot unless the EULA has, most of them from most vendors, unless the EULA has been accepted. So again, the deploy VM wizard is reading that configuration that we've stored in the database. It's reading the fact that it's got a license agreement or multiple license agreements that have to be agreed, and forcing the end user to actually agree those license agreements. And again, there's displayed, and this is, completely data driven, depending on what CloudStack finds in that configuration, which is stored in the database, that's been imported from the OVA, is what it then displays during the create VM process. Paul, you back in the land of the living?
I hope so. Yeah,
brilliant.
I hope so.
Okay. Well, I might as well finish. You can go straight.
Yeah, I'm sure the demo god's not liking me, but the presentation gods are usually on my side.
Yeah. Okay. Are you ready to do a demo then?
Yeah. Let me grab where that's gone and hope it doesn't crash for me again.
Switch back over to you. You want to let me make you a presenter for some reason. So
in here, what we've got is a kind of test demo environment. You can see we've got a whole load of templates in here, and so we know which is which. You can see a kind of as is stuck on the end of some of these, so we know what's what. You can see this one, I think it was the last one I added. It's decided the operating system as the template, and I've just gone to a normal registration wizard to get that, which I think you saw earlier in the screenshots. Now going forward, I'm going to say I want to create an instance here. I can keep all of that the same and find my ASAV. Now, you can see, actually, if I take that to just a normal template, this just looks like a normal setup. If I say it's an ASAV, suddenly I have my compute offering, which is the underlying offerings that the OVF presents. And it's quite clever because I pick one of these, and then it's changing the compute offering in the background So you can see the description that the OVF gives and saying, well, if you have this, then you should have that. And if you want a 2 gigabit, then you need the 30, which has this. So all of that is following exactly what's in the OVF in the first place. And you saw the screenshots. You can see the like for like images of the screens that you would see in vCenter versus CloudStack. The ASA V, as you can see, needs a whole load of different network information. What's connected where? What's it going to do? Obviously, as we said earlier, also the order is important. In this case, the management is one, and then the other interfaces come after that. But when it's deployed, these positions, slots as they call them, are maintained. So everything ends up where it was. You don't end up with the wrong NIC not connected where you expected it to. So that's all taken from the OVF. And then again, as we said, here's your properties. Say this is an ASAV, so everything you see is what it would be asking you. Host names, drop downs populate as per drop downs in the OVA, on and offs again. So we kind of work out or read what type of input it's requiring, and then putting that in. And if there is a default, we would use it. There often isn't, but if there was, we do. And you've got the actual explanation here, as would be presented in the OVA. So people, if they've worked out what to do with the OVA and vCenter, can come in here, and the experience won't be very much different. It's going to be asked the same questions in the same way, even in the same kind of property spaces under the same headings. And all of that would get propagated through, and then we're back to our normal kind of things you might want to give, like details, group, possibly keyboard language. And then, as we say, if I try and click this and haven't accepted the agreement, it's not going to let me go any further. We've picked that out of the OVF, that's one of the few absolutely required fields, so we honor that. You can't go any further. If you were trying to bypass it via the API, you would get the same kind of answers from Vsphere. No, you can't. I'm not doing this because you haven't accepted the license. So that's the kind of seeing it for real run through of what you're looking at. And also, interestingly, as you'll see, this gets populated as you start changing things, which is kind of nifty as well. So that is that bit of demo. Now, where are we? Okay, there's dynamic roles me, Giles. I can't remember who's doing that. I guess it is.
Yeah, you go for that.
Cool. So dynamic roles, and it does segue into projects as well. So what we've done with dynamic roles is they can get very big. There's 600 APIs, I think, and potentially you could create rules around every single one of them. So it's pretty massive. So what we've done is enable people to clone an existing role, and then they can just make some changes to it. And then potentially they want to share that in some way, so they can export it, maybe to back it up even, and they can import them as well. So you've got a lot more control over these roles, and just made life an awful lot easier. In addition, because there were some particular use cases we were thinking of when doing this, we've added them as default roles. The roles themselves are read-only as default roles. You can't change them, but you could clone them, just call them something else, and you reuse them or just alter them slightly. So you've got these ideas of read-only people. So you may have an administrator that you want to give rights to look at things, but you don't want them to be able to add hosts, delete hosts, or do anything dangerous. So those kind of list APIs are allowed. The destructive and do things APIs, adding APIs are not available to it. The same with a user. There may be a user who needs to see things from maybe accounting or something, but you don't want them destroying virtual machines. That's added in there. and support admin, support user kind of sits somewhere in between, where there's operations you might want to do, start-stop VMs, but you don't want them going on and deleting them. So we've included all of those to work with, and that's explaining those default roles in a bit more detail, but you can see what they're allowed to do, i.e. not change physical networks or mess around with hosts in the admin role. Now, the projects part of this then becomes very interesting, because what we've changed is you can now add users as well as or instead of accounts. So you've got a lot more flexibility around there. You don't have to add the whole account into a project. It can be an individual user. On top of that, we've combined it with the dynamic roles so that each user in each project, or the same user in each project, can have different roles. So within a role, within a project, you can define specific roles. Again, they can be completely custom. You can then add a user to that role, and that's fine. But in another project, that user could exist, but they have a different role in that project. So they may be a support admin in one project, but actually a full admin in another. So you've got massive flexibility there of how you work with projects and how people live, if you like, inside projects. And a lot of the other functionality is still kept, where you have the option to either invite people to a project or be able to, as an admin, just add them because you want to. And there's still the global setting that says, actually, you're not allowed to just add people, you must invite them. And another very nice thing is you don't have to have just one admin anymore. Multiple users can be the project admin. So you don't have that single point of failure, if you like, of, well, only one person can do this and they're on holiday. You can now have any number of users being admins to that project. And you can see the role type there against the project. We're getting on, so I can hand back, I think, to Giles.
Thank you, Paul. There we go. Okay, so next feature, Redfish support. Okay, so CloudStack's got a bit of functionality that's been around for a few years, out of band management, which allows you to control the underlying hosts traditionally through IPMI, and that sort of functionality is also used in the host stage, the KVM host stage A, which has been around for a few years. Fundamental problem is IPMI is not being developed further. It's effectively a dead person walking, and most of the big vendors are looking towards Redfish from the DMTF body as the replacement for IPMI. So this is a new out-of-band management driver or provider, which lets you basically do exactly the same stuff in CloudStack, but it's using Redfish under the surface instead of IPMI. It's a lovely little bit of work. It was done by our friends over at PC Extreme in the Netherlands, and basically, if you configure out-of-band management now for a host as well as the IPMI option, you've also got the Redfish option. And what that's doing, that's the entire architecture of the out-of-band management piece in CloudStack. And really, all this is adding a second driver into that place. And it's a very nice thing to see that actually when the out-of-band management work was done, that there was an extensible driver-based model was created at the time for exactly this scenario. So it's really good to see the Redfish support going into there. Boot into hardware setup, very simple bit of functionality. So only for VMware at this stage, but when you deploy a VM, you can specify to boot into the hardware setup menu. The use case around this, obviously, you want to change the boot order or something of a machine, and the problem was always traditionally you would click launch VM and then quickly try and get into the console to press whatever keys were necessary to get into the setup, and often the console wasn't ready and you'd already missed it, etc., etc. So now you can just tell CloudStack to tell the hypervisor, put it into hardware setup, and then when you launch the console, it's going to be at that point. This is a nice little improvement. Human readable logs. Well, human readable values in logs. I'm sure everybody on this call who knows CloudStack knows how frustrating it is that we've always had the raw byte values in our logs, in usage records, and you know, all the logs across the virtual router everywhere. We've now got both. We've got the raw byte value, plus we've got a properly formatted gigabyte, megabyte, terabyte value as well, which just makes the logs a lot more readable and saves you making the mistake of getting an order of magnitude out, which I'm sure you've all done plenty of times. Another nice little feature is now the ability to, as the administrator, when you're configuring the service offering, is to enforce or preset the root disk size. Okay, so you can effectively hard code that root disk size. And what that does, it stops the user from choosing their own root disk size and always will use that root disk size. Obviously, you know, a lot of people will still want the user to be able to do it, in which case you can just leave it set in that direction. But when you create the compute offering, you can now specify a fixed offering with a fixed root disk size. And the only way that a user would be able to change the size of their root disk would be to move it to a different service offering. Final one is, for me, the best thing in 4.15, because this is life-changing for me. We've got a new console, right? So the console that CloudStack's had, it was effectively a homegrown thing. It's been around since the first version of CloudStack, and as I'm sure everybody knows here, it was really slow. Frustratingly slow, and it did it because it was rendering images directly, and that was via lots and lots of API calls, had massive performance limitations. So we've thrown that away, dropped in noVNC, which is an open source console JavaScript library, okay, which uses WebSockets to connect. It still connects to the VM console. I can't remember the console VM behind the scene. So it's still connecting to the same thing, but it's a lot more efficient. To switch it on, there's a global setting in 4.15, noVNC console default, set that to true, bang, it changes and starts using the new console. Dramatic performance increase. It supports any keyboard layout supported by the VM, and even allows full screen and pasting into the console at long last. Simply because I feel I really need to do this. I just need to show everybody this if you haven't seen it already. So if I just go and find a VM, just to give you an idea of the performance. Obviously it has to be a running VM. Okay, launch the console. Bear in mind, this isn't local. I'm VPN'd into our lab. There we go. And I don't know if you can hear my keyboard, but if I start typing, it's real-time performance now. It's a much better experience. We don't have those tiles disappearing out of it or anything like that. It's a much nicer experience. Okay. Right, that's pretty much it. We are just talk about this. Anybody who wants to get involved in CloudStack, to use it, please feel free to get involved in the project. Just from the website there, go and find one of the mailing lists, join one of the mailing lists. Further reading, the release notes aren't there yet because the 4.15 release isn't actually out yet, but that will be the URL for them. And at ShapeBlue, some of the guys who have worked on some of these features have done some blog articles and some videos around the things they've been working on. A lot of the things we've talked about today, if you look on our blog and look for Feature First Look, you will see a lot of these things actually discussed in more detail than we've done today. It's exactly 4 o'clock now. We're going to start going through the questions. We have a lot of questions. I say we'll probably cap it at 15 minutes. But I will also follow this up with some of these questions on email as well. But that's the hour, and thank you for listening, anybody who has to drop off. So we'll start going through The questions. Okay. First one is from Gabrielle. In another version, you talked about Project Primate for the UI. Is that the same thing? Is that still a thing? I think I mentioned this earlier, Gabrielle. Primate was the code name for the new UI. That code name is now being dropped. So the new UI is what was Project Primate. But in a few months' time, by the next release, you shouldn't hear that term at all. Misha, can I get a pre-release version of the software to look at now? Yes, you can, Misha. I'm going to say the easiest thing to do, jump onto either the users or the devs mailing list. In fact, the first release candidates are being cut and people will soon start voting in the community on these releases. So you can come in now and get a release candidate when it's cut. You can even participate in the testing and the voting if you wanted to. So you can do more than just have it to play with. You could actually give some feedback for it right now. Phil, what do I have to do to deploy the new UI? Nothing, in short, Phil. You just installed CloudStack 4.15. The new UI is packaged with it. Pradeep, will the new OVF feature support appliances from Riverbed? Yes, as long as Riverbed have appliances that are packaged in the OVF format, right? So that's the whole point. This is extensible. It doesn't matter who the vendor is, as long as they're packaged in that format, you'll be able to deploy those appliances. And to be frank, you've always been able to deploy appliances, but what we've got now with the full OVF support is the ability to read all that configuration information and set all of that without you having to go and sort of look it up manually and that sort of thing. Alan, I like the way I can now deploy virtual appliances. Are there any plans to be able to use those appliances in a CloudStack network? Yeah, I mean, again, you could do this already. You can bring appliances in and hook them up to a layer 2 network. I think what you're getting at, that there is a lot of work going on. You've probably heard people talk about before with the CloudStack next generation networking, which is about the ability to start to service chain with CloudStack's appliances, i.e. its virtual router, and with other devices. And there's a lot of stuff going on around that at the moment, and you'll start to see some of that in successive releases. That's where it gets really interesting and really exciting. But there's nothing to stop you today bringing an appliance in and hooking it up to appropriate network. Paul, I don't know, you got anything to add to that?
No, I mean, I was reading some of the questions as well to make sure we're up to speed on them. No, I mean, yes, you could use them before. Now it will be much better, and they could go in port forwarding on VR, or basically isolated networks, shared networks you can use them on, and then the new L2 networks you could use them in. They'll be very useful in those. And as Giles said, the stuff we're doing to have the next gen, where basically, for instance, your Riverbed or your ASAV can actually replace the virtual router, and you sit that at the very front of your networks, is where we're going with that. So yes, you can already, but we're going to turbocharge it and put it on steroids shortly.
Cool. Thank you, Paul. Next question is from Rob. Will we need to use the new UI for vSAN support? I know, Rob, you're very keen to use vSAN support. Okay. The official answer, I think you're picking up on what I said at the beginning, which is none of this new functionality is in the old UI, which it technically isn't. But actually for vSAN, there's I can't think of a reason. There's nothing in the UI that actually to use vSAN you require, because it's just a question of specifying the type when you set the data store. Paul, am I correct there?
Yeah, it's it would still be pre-set up. So from a UI point of view, that's no different. There are, for instance, storage policies, which I think vSAN kind of wants to know as well, that you would probably have to set up either using the old UI or via API, but it's not customer facing, as it were, that part, it would be the operator rather than users. So that would be not a showstopper, as it were, not a blocker to doing it. Once it's there, anyone would just say, yes, preset up, that's the name of the store, and the new stuff in the back end would do it. But from a UI point of view, you wouldn't need to know about it.
Okay. So the next one is from Rakesh. Rakesh has asked, this is sort of two questions. Is inter-cluster VM migration is enabled by default, or do we have to turn it on somewhere? And also, can a VM be migrated without migrating a volume? I don't know the answer to either of those. Do you? Hopefully you do, Paul.
Yeah, hopefully I do. No, inter-cluster VM migration has always been there for some hypervisors and for and for when there's zone level storage. So it's not a case of switching it on and off from a new feature perspective. It's just the case that now Vsphere supports it. And I think you probably see when you're seeing if you try and migrate a VM, you'll see a message such as storage migration required. If migrating a VM between hosts meant it had to change storage, like going to another cluster. So this isn't new in that sense. It's just new and faster and better in Vsphere. In terms of migrating just the compute, well, that really depends on your storage, because if for instance, you can do the live migration across where there isn't shared storage, but you can't run a VM if the VM itself, compute, can't get to its own disk. If you were using zone-wide storage, then yes, you're just moving compute, and that's fine. But if, for instance, host A in this cluster, it can't run the compute on there if it can't get to the disk that's in cluster B. So it's the good old "it depends" kind of answer. But that's kind of the things it depends on.
Good, thank you, Paul. Jennifer has asked, thanks for the new console, looks great. Do I have to do any configurations to allow to access it? Short answer is no, Jennifer. It's still using the thing that's name I couldn't remember. Paul, help me with this.
CPVM.
Thank you very much. Console proxy VM. Thank you very much. That's still effectively the endpoint. So no, you don't need to start opening any ports up or anything like that. Tariq has asked, could I use the new OVS appliance stuff to sell networking devices to my customers? I know Tariq, won't mind me saying, runs a public cloud environment. Yes, that's sort of part of the point there, Tariq. Effectively, yeah, you're adding. You would add templates for the devices, the appliances that you want to sell. Your users are then going to be greeted with all of those prompts that Paul was showing us. It's then just a question of you, through your usage stuff, working out how you would charge people for use for creating instances of those, i.e. appliances. You might get, you'd have to obviously, make sure your licensing is correct with the vendor at the back end for you to be able to sell it as a service provider. The end user is accepting the EULA and the license agreement, but there might be some extra sort of commercial stuff you need to do with the vendor behind the scenes. Okay, Francois, how can I give feedback on these features? From a community perspective, this is a community release, Francois. So, go to the CloudStack mailing list, go to CloudStack on Apache Cloudstack on GitHub. You can create an issue if you found problems. If you jump on the mailing list, you can have an open discussion on there, feedback, stuff you like, stuff you don't like. Now, as I said, is a really good time because voting will be going on with this. So if you want to put feedback in, now is the time because the community will be at the point of deciding exactly what the release looks like. If that all sounds scary, Francois, drop me or Paul a line and we can sort of take feedback in for you. Lucas, we're using the CloudStack Kubernetes service. You've not mentioned it here. No, because there's nothing new. Lucas, in 4.15, CKS was came out in 4.14. There is actually, I know, work going on in CKS. There's some really interesting stuff. There's auto scaling, which is really interesting because that then gives the ability for Kubernetes to tell CloudStack that it wants to scale and start to scale the infrastructure. It's just a timing thing. I think there might be a bug fix or two that's related to CKS, but no new functionality in this particular version. Paul, you might have to look at these next couple. Deepak's question, vCPU pinning support for KVM virtual machines.
Now, I'm dredging my memory, but a feature that was added, I think, in 4.14 was called arbitrary configuration data. And what that allowed you to do is basically send extra XML. I think we were using it to, for instance, add huge pages and NUMA support in there. So I think you can add that, or you do add that via the XML, usually in KVM. So yes, from that point of view, as long as you can add it to the XML, we pass that through to the VM. It's probably worth noting we operate an allow list on that, so people can't just start adding whatever they like to VMs and potentially take over your hypervisors or break things or what have you, whatever else. So as a cloud operator, you have an allow list that says these are the things, the configurations I will allow through, and same for VMware and Zen Server as well. They all support this. These are the configurations I will allow you to pass through, but anything else I'm just going to strip out and I'm not going to send to the hypervisor for that virtual machine.
Thank you. We might have to stick with you, Paul. Ricardo, what about SSL offloading on HA proxy on the VR? Is it in this version? I think the answer is no, but I'd better defer to your greater knowledge.
I don't think so. I saw that coming up and I did a quick, literally a word search through the list I'm creating as our RM manager of what's going in, and I couldn't find that. So I'm going to have to say I don't think it is either.
Okay, maybe we could get back to Ricardo about that. Carly, you've asked, you've found the milestone, the 4.15 milestone in GitHub and said, hey, that says November 15th. Can I use it on November 15th? That's probably slightly dated. It slipped a little bit since then. I think it would be very unlikely. In fact, it won't be November the 15th. Roughly the end of November, I think, is the best date to plan for. Last question. Valibav, live migration with Ceph as primary storage. Is it available? Paul, could you do that one?
The answer is no, I can't do that one. I think that's one that's kind of controlled and run by the people who support the Ceph. They like our kind of plugin mechanism. Ceph is one of what we call the managed storage providers. So it's kind of looked after by those providers. So it's kind of outside of CloudStack, if you kind of understand what I mean. It's obviously in CloudStack, but it's maintained by Ceph people as opposed to CloudStack people. I'm just doing a quick search for that in, again, my starting off release notes. See if Ceph appears in them anywhere. Port numbers been specified. It doesn't look like it's been added anywhere at this point.
Okay.
It would be the people who maintain Ceph as a storage provider to CloudStack, if you like, would know better or know if and when they're planning it.
Okay, well, not being able to answer one out of however many questions that was, I suppose, isn't a bad record. Okay, let's wind it up. It's 1:15. So thank you very much, everybody, for coming and listening. Please do get on the mailing list and try a version of 4.15. If you can get hold of one of the release candidates before release, it'd be fantastic to get feedback before the release. If not, as I said earlier, release is scheduled roughly for end of November. Thank you very much and take care, everybody.
Thank you.